Welcome, data enthusiasts. We are Zuma, the recruitment consultancy focused 100% on data tech professionals in and around the Berlin region. And this is our podcast, Data for Good, connecting you with all things data. And today, great to be joined by Eliott Kalfon. And Eliott is data science team lead at Auto1 Group. And a quick one about Auto1 Group. As you probably know, Berliners, it's the Berlin-based online car selling platform with over 3,000 employees at least and millions of daily transactions, really strong data science, analytics and engineering capability here in Berlin and even throughout the country. Eliott, how are you today?
I'm good. Hi, Joseph. Very happy to be here.
Awesome. Good to hear it. And today's topic, we're going to be talking about machine learning for pricing. And yeah, this will be fun for me, being slightly on the technical outside, but it's often a requirement or a skill set that gets told to us when we go looking for data professionals. So yeah, I'm really keen to get into this. Give me the context then. Tell me what we're going to be exploring today, really high level.
So today we'll be exploring pricing and even beyond pricing. How could machine learning be used to tackle tough problems?
Super, super. Pricing and beyond through the eyes of machine learning. Super. So when we talk about and think about machine learning for pricing, the algorithms that are used, where are they typically taken from? What kind of data are you taking to create pricing algorithms?
So there, I think, two questions: the data that we're taking, and then how the algorithms are actually created and what they look like. I could start with the data that we're taking. So one of our strengths at Auto1 is that we have been in the market for second-hand cars for the last 10 years. And we have 10 years of historical transaction data. And this is it's a crazy rich asset when you think about it. And so we have two ways that we use to price cars. The first is with human prices. So there, the idea is that customers would go to our website via Kalfon Auto, fill in the details of their cars, and then send that filled in form to us. And then this form would be studied or checked by pricers, and then they would give a price, and that would be it. So this would be the human pricer way to price cars. This is something we have done and we still very much do. Then we could also use machine learning to do that. And when we use machine learning, we start with the data, and there we looked at anything car related. So what car are we talking about? Is it the make, model, what manufacturer, what the car actually looks like? We also look at the condition of the car. Is it in good condition, bad condition? I'd say anything between good and bad. And then we also look at everything outside of the car. So what happens in the market, what happens in the world.
Okay. And there are many factors, what happens in the market and what happens in the world. We might, I'm not sure whether, when you look at clothes shopping, sometimes seasons and sales come into play. I should imagine with car shopping, it's quite different, but I'm sure there are other pulls, other demands. Okay, very good, very good. How much does human interaction come into the decision-making process where machine learning is involved now?
So in the whole process of a customer coming to us, Auto1, and then selling us their car and us selling the car back to either customers or dealers, there are a lot of human interactions in that entire process. It's important to know. When it comes to the pricing process itself, if the car is going to be priced by humans, well, of course, the interaction happens there. However, when it's priced with machine learning, what would happen is that once we have the details of a car coming to our platform, the details are transformed into a machine readable format. In practice, just a list of numbers. And then we send that list of numbers to a machine learning model, and from there get a price. And this is the price that would then be given to the customer.
Okay, so you have the more traditional pricing way that's humans trading, and then we have machine learning coming into play. If we look at the building of models, what is the human interaction or the human checkpoints, be it of data professionals or otherwise? What are those human interactions going on in terms of data collection, preparation, model interpretation even?
So their human interaction or human input is going to be present at every step of the way. So we start with human input at the beginning to define the problem. And that goes for any or most of machine learning projects, at least I am aware of. You have to have humans to define the problem that the algorithm is going to be solving or tackling. So before we even start, we have human input and discussions, business priorities, how we allocate resources. So it's a very human problem at the start. Then in the development of the model, we also have a lot of human input. So using as much business knowledge as we can, we also gather all of the data we think could be relevant. And then we enter a phase of experimentation, try out different models, and then see how they go. So that is in the development. So that's also a lot of human input. After that, we would have a phase of experimentation. By experimentation, I mean trying out the model with actual pricing requests on our platform. And it's usually done through A/B tests, which I think is a term that is quite common in the industry. It's also very much a best practice when it comes to deploying machine learning models. And there, with a decision to continue the experiment or stop the experiment or fully roll out a model, there we have a lot of human touch points as well. And I would say, lastly, when a model is deployed, you have a lot of human input when it comes to maintenance of that model, and also when it comes to monitoring. So making sure that the model performs as expected.
So there's maybe unbeknownst to the business professional, the sales professional, or at least the non-data professional, there's actually constantly human interaction and human intervention and human input in machine learning building and maintenance. Good for those folks to know who perhaps don't trust the accuracy of data, which, when you look at 10 years, you spoke of 10 years of data collection for Auto1 Group. That's a whole load of evidence to be basing your pricing models on. As you mentioned models, could you tell me about some of the models involved in machine learning for pricing?
Yes. So here, what's important to note before I get into looking into just one or two models is that a lot of different models could be used for pricing. So I'm just going to mention one or two because the goal is not to use the entire podcast for this. But yeah, we could use a variety of models to get into these.
Before you do, can I also ask, the models used for pricing by Auto1 or any other trading platform, would they categorically be different to models for other industries like retailers, FMCGs, those kind of businesses? Because there's still sales transactions going on, there's still pricing going on.
Exactly. So in general, these models would be similar to not only pricing tasks in other companies, but to a lot of other problems that could be solved with machine learning. When you're thinking of types of models or types of machine learning problems, you would usually go along the line of three main categories. You've got one, which is classification, when you classify something, or the idea is to predict a class or a label. Then you have models that are regression. So these you try to predict a quantity. And then you have reinforcement learning, where you're going to be predicting an action in an environment. And any regression task or any regression model could be used to solve any regression task. So we could predict with the model we use to predict, let's say, price. We could also predict any other finite quantity,
Mm.
for instance.
Machine learning algorithms are not always correct. This is where I'm going. And I wonder when it does go wrong, particularly with pricing, the business impact is loss of revenue. How is it going wrong? Excuse me. And how can it then be resolved or rectified?
Okay, I think that's quite an important question to ask and also to answer on our side. So I think the first step there is to try to solve the problem before the problem actually occurs. So it's on the prevention of these errors. And I think that we could do a lot there already. What I mean by this is we are never going to let a machine learning model price cars on its own and make decisions for a business on its own. So this machine learning model is embedded within a larger system that applies business logic, and we have some rules to make sure that we lower the risk as much as possible. Mm-hmm. So we also have a large variety of tests applied to these models, also a large variety of tests applied to the software system that is our predicting mm-hmm. service, just to make sure that we reduce the risk of error as low as possible. So I think a lot of it is in prevention.
I would assume that this is also, it's not just Auto1, it's machine learning best practice, what machine learning engineers across Berlin and across the world should be adhering to. Okay. What challenges do machine learning engineers face every day when they build machine learning pricing models? When I think of these engineers that we recruit and we hopefully successfully employ within clients of ours, what are they struggling with every day? What are the challenges that they face when they're building machine learning pricing models?
I would say the main challenge is that these engineers are building and then deploying pricing models or machine learning models in a world that is continually changing. The moment you train your model and then deploy it, I mean, the second after that, new information comes in, reality starts or continues to change. And so for that reason, it's actually quite difficult to make sure that a model which has learned from history can still be accurate enough in the future, or at least 1 day or 2 days or 3 days or a week after it has been returned, or 2 weeks or 1 month. So I think the main challenge is to build these prediction engines in a widely changing world. And what I mean by these changes, we can think of, let's say, pricing, the change of market trends that happen. So at Auto1, we have, let's say, a price index that we release every month, I would say, just to measure the variation of prices in the second-hand car market. So these are market trends.
Mm. So, here's another, excuse me. Here's another topic or another element that's people related, and we've talked about data coming in and then machine learning engineers immediately working on it. There are people and there are processes in between there. What's happening before? I suppose we're going to go into the topics of data engineering potentially, but I'm thinking about the human elements and the skills, the people skills that machine learning engineers now need to develop as working professionals. So what are those challenges for machine learning engineers on the human side?
Definitely. So as machine learning engineers, you never work in isolation. At least in my experience as machine learning engineer, I've never worked on my own, especially when deploying a model. First of all, because as you mentioned with data engineering, a model is only as good as the data that it gets for training and the data that it gets at prediction. And if that data is not good, if it's not correct, if it's not clean, the model is not going to perform well and we won't get accurate predictions. But it's not only about data. a machine learning model in production is also a software system. It's a microservice. So if we have some problems, let's say, on that current API, so if the clusters or the servers are not healthy at that point, then there will be no response from that service. So if we ask for prediction, we would be getting code 500 in return, or errors from the server in return. So it's also with the IT side of the business that we need to be very much in collaboration with. And then lastly, this machine learning model is going to make decisions which have a very large impact on the business as a whole. So there's also constant collaboration with the business team. And when we talk about managing the business risk associated to a machine learning model, this is also in close contact with business leaders at Auto1, and I would say in any other company too. So we're really always in contact with both technology team and also the rest of the company.
Fantastic. I want to talk about the future and the evolution of machine learning. The biggest crazes or the biggest hypes right now are generative AI and AI generally speaking. I wonder where you see the future of machine learning for pricing going.
Yes, and
how the challenges might change, how the tasks might change.
Definitely. And I think just generally in the field of machine learning and artificial intelligence, everything now changes so quickly. So yeah, this is definitely something that we're closely paying attention to. I think also what these new findings in generative AI show is that we do not need data to be cleanly formatted as a list of numbers to actually do machine learning. Data doesn't have to live in a table for us to be able to actually use machine learning. These Gen AI models show us that with language, we can then predict more language, or we can generate more language, which is much more than prediction. And this is very exciting because it also means that there is a lot of data that we could make use of. Data like text, or data that is not going to be structured. Let's say long
a lot
lists,
of data that we're not currently making use of.
That, yes, I mean that we're not currently making use of, or not fully. We could always make more use of the data that we have, I would say. And so, yeah, we could actually use text, we could use non-structured data, and we could use new models to take care of these complex inputs, I would say. And in the future, use that for prediction of quantities. We go back to the regression problem that we were mentioning, but also, why not actions? I don't see the need for text generation when it comes to machine learning for pricing, but who knows? We may be surprised again, but I don't see it yet. But that being said, I think in terms of future of machine learning, and machine learning for pricing, it's especially leveraging these complex data sources, like text and non-structured data. And also, I would say, as an additional challenge is, and I think this is still not a solved problem, is we're talking about predicting a price or using history to predict a price. So yes, that is one thing that can be done. Another thing that could be done is, instead of trying to predict the price, so as a regression problem, is also trying to find the best price. And here we come to the field of action and of optimization. And this is also a very different problem, and also very exciting if you look at the technical aspects of it.
I also think from the business perspective, how machine learning will start to integrate more and more with other disparate systems across an organization, like the elements of the ERP system or the CRM system that other teams are using. Yeah. As a quick one, there are go-to tools for machine learning engineers. For somebody, quite often it's a data scientist or a data analyst wanting to get into machine learning. What tools would you recommend they start using in their free time or even their work time to evolve skills in pricing?
Okay, so I think that there are a few aspects. You have machine learning engineering, and then you have pricing. I think that to perform well or to be able to solve pricing tasks with machine learning, I don't think any specific knowledge to pricing is necessary. It will never hurt, but I don't think it's necessary. What I would say is, if let's say you're a data analyst or a data engineer, or working even remotely with data and want to get into machine learning engineering, I would consider two aspects to it. The first one is the machine learning, and the second is the engineering. And when it comes to machine learning, it's looking at machine learning theory, so the statistics behind machine learning models. I think this is quite important to know. And then also how we could use code, let's say Python, to get these models to run and to train these models and to use them to generate prediction. So this is really the machine learning side of things. And then also on the engineering, it's looking further into code, so how we could actually build API or microservices using code, and also looking at how we can integrate machine learning models within larger systems. And there I would be looking at SQL to be able to get data from large databases, also looking at HTTP protocols and how we could get systems to talk to other systems to get data when it comes to making predictions. So yeah, that would be where I would start.
Interesting. Eliott, you've shared a lot today, and in one very specific topic. I really appreciate you going deep into pricing for us. We looked at how pricing is typically done, machine learning pricing, that is, some of the models involved. We looked at the human interaction and how that impacts accuracy, some of the challenges involved as well, and then the future. Are there any other points that you would add on our conversation today?
I'm trying to think. Yes, I think a lot of what we said was focused on pricing, but also a lot of the concepts mentioned could be applied to solve a lot of other similar problems. So even though a lot of our examples were related to car pricing, still I hope that this conversation could be useful to anyone looking into machine learning and applying machine learning to business.
I would certainly expect so. Eliott, thanks very much for today. Really appreciate it. And I shall look forward to hopefully having you on again, where I will quiz you about another specific machine learning topic. And yeah, until then, see you next time.
Thanks, Joseph. I look forward to it.